Thank you. Wonderful to be here. It's my third time speaking, I guess, on Postgres in Armenia. I wasn't sure I would ever. It continues to surprise me that my Armenianness and my Postgres have collided. It's a very unusual thing. We are actually planning a conference in April.
Yes, but we will talk about it.
We'll talk about the end. Okay. I actually am coming here from China. We had a conference in Hangzhou, China, on Saturday of the previous week, and what we're basically trying to do, my company EDB is basically paying me to grow the Postgres community around the world. I've done it in Russia consistently and other parts of the world, and I think hopefully next year we're going to have a more consistent approach to growing in China and of course in Armenia as well. So whatever we can do in both those countries, I would be glad to do. China actually sent us some candy. Or you see in the back, there's like a little candy thing. It's kind of interesting. It's like a local almost with a candy on the outside. Is that a good description?
No.
No.
It's like shortcut on the outside.
Shotcar on the outside, yeah.
Caramelized something.
Very caramelized.
Very
Munch your
caramelized,
teeth.
some kind of local on the inside. So I thought it was quite good. So we have some back on the table there. Just to give some introductory remarks. Obviously, the first time I came to Armenia was 2004 with an organization called Silicon Armenia, and the idea there of that event was to help to build open source opportunities in Armenia, because Armenia has a very good work environment and very capable individuals, but at that time there were not many tech opportunities. Now, of course, we're 20 years later, but still, I think open source is a great opportunity for engineers in Armenia to be involved in. I know many of you may use open source, but you should also realize that there's a whole team of people who work in the internals and the development of that open source software, and there's some very big companies that fund people to do that. So my point is that effectively, I know, for example, we're at Microsoft has a team of about 40 people around the world whose only job is to help the Postgres community. So again, there are great opportunities available. The talk I'm giving today is effectively about generative AI. It's a kind of a new topic in the past 3 years, and I'll be going over some of that history, and I'll explain how it works, and then at the end, I'll talk about how databases can be used for generative AI. The slides are actually right here at this website. There are 64 presentations about Postgres at that website, and this is the QR code that goes with it. So if you'd like to look at these slides or videos, there's 130 videos and probably 600 and 700 blog entries about Postgres. So a lot of material there. I've been doing this since 1996, so when you've been doing it as long as I do, you end up accumulating a whole bunch of material, and it ends up all on my website. Okay, so what are we going to talk about today? I do have a talk about discriminative AI, which I will not be discussing today, but again, if you're interested in that, feel free to go to that URL, also the URL, anything in blue here. If you download the slides, you click on them, you'll get to the website, okay? So first we're going to talk about the AI explosion. How did we get here? Everyone's talking about it, but this talk is going to be a lot more than just talking about it. Section 2, we're going to start to dive into some of the details of how AI works, how generative AI works, because unless we understand how generative AI works, we can't understand when a database makes sense. So again, the idea of this talk is we're going to explain how generative AI works, and then once we understand how it works, we can then figure out how to use it in our applications. Section 3, we're going to talk about something called text embeddings. You may never heard of that term before, but at the end of this you will. Then it will talk about semantic or vector search. And then in 5 forward, we'll talk about generative AI, things called transformers, how generative AI works. We'll talk about something called retrieval augmented generation, or RAG. You may have heard of that before. We'll talk about deployment of AI, and then finally conclusion. Okay? So we do have, I'm sorry, 87 slides, but anyway, it'll go through pretty quickly. Okay. So I said that AI is fairly new. It's exactly about 3 years old this week. So on November 30, 2022, ChatGPT 4 was released. And it made a huge impact because it was the first time that people were able to interact verbally or textually with a computer in a way that wasn't sort of predetermined, right? And we're going to explain how that works today. I have a URL here. This is a 6-hour video series. If you want to, that is the best set of videos that I've ever seen in the internals of generative AI. It is very complicated. So I'm just giving you a warning. Very complicated, but again, you download the slides, click on it, it'll take you to that, and you can look at that. Okay. Sorry. I'm sorry, that's a little slow. Yeah. So up until 2022, what people thought of for AI was something called discriminative or predictive AI. All right. And predictive AI effectively did things like classification, recommendations, predictions, and language translations. So again, up until ChatGPT, this is what we normally thought of as AI. So if you were recommending doing a web search, or you were checking for image recognition, these were all discriminative or predictive AI. Generative AI, which is what we're going to be talking about today, is really something that only started with ChatGPT. Now, there's a whole lot of new ones now, but again, the first one was ChatGPT. Now we have Gemini, we have DeepSeek, we have Llama from Facebook. There's a whole Hugging Face. There's a whole bunch of AI now, but again, first one was that, right? What are the use cases for generative AI? Originally it was like chatbots, but it's become much more sophisticated. I'll talk about semantic search today, summarization and language translation as well. Video creation and image creation is kind of cool. Some of the software uses for generative AI I think are very compelling. Code creation, we talked about, what's the name for that? Where you ask AI for some code that generates it for you.
Agents.
Vibe coding.
Vibe coding, yeah, vibe coding. It's kind of a trend. I don't know if it's a valid thing or not. I'm not a super fan, but anyway, it's something. Code analysis, it does a very good job of that. Data analysis. I've been very impressed with some of the conversion from one language to another, which it could do stuff I didn't think was possible. So I'm actually holding out a lot of hope for that one. And again, I have a URL down here. So again, I think there's some really interesting use cases that will be coming up. Just to give you a general outline, discriminative is supervised learning, specific, usually a specific problem domain. Generative AI, obviously much more general, but needs a lot more data to actually work, okay? And again, just a quote here, generative AI is basically generating new content. Discriminative certainly did not do that. So that idea of generating new content, that's what generative AI is. This is an image of discriminative. It's trying to discriminate a dog from a cat. And again, it's trying to find the boundary line between those categories, okay? Generative is really related to vectors, and that's what the next section is going to be about, okay? Any questions? Okay, all right. So, If you don't like math, you are not gonna like this section. There is no way to describe generative AI without talking about mathematics. Because the foundation of what makes it possible is math, all right, particularly vectors. And what I'm gonna explain is exactly why that is true, because it isn't obvious, but I'm gonna walk you through some of this. I will tell you, it took me several weeks to write this talk, and maybe a month or a month and a half. Because what I found was there was a lot of information available on the internet, but because the field is so new, there were little pieces of information. So you could learn like, oh, this piece is this one, this website talks about this piece, this webpage talks about that piece. And putting it all together was actually really hard. And that's what I think is interesting about this talk. So let's talk about let's talk about math. Math allows you to represent things that are not, that they can't exist in the physical world. For example, the number of atoms in the universe is 10 to the 80. Now, I have no idea what that means, right? I know what 1,000 looks like, because I've spoken to some groups that are almost 1,000, but I don't know what 10 to the 80 looks like, and I don't think anybody here probably does. But mathematics allows us to represent it, all right? The idea of infinity, I'm not sure how, I was a math major in college. The idea of infinity is, again, very easy to represent in mathematics. There is no infinity in the real world, right? At least we don't normally deal with infinity. Things like calculus, the derivative is the sum of basically an infinitesimally small slope. An integral is infinitesimally small number of slices, okay? So when you think you're doing integrals or you're doing derivatives, you're manipulating infinity, even though you can't physically represent infinity in the real world, okay? So again, mathematics allows us to represent something that we can't really represent in the physical world. There's another concept in mathematics called duality, the concept that you can effectively represent the physical world and computer science things and abstract representation, and they're all really the same. Again, feel free to read that if you're interested. It's just a concept, because I keep bouncing between the physical world and the computer world and abstract representations during this talk. So let's talk about generative AI. So generative AI typically uses vectors in the 1,000 to 12,000 dimensional space. Now you can probably understand why I talked about infinity now, right? And the number of atoms in the universe. Because I don't think anybody in this room can really conceptualize what 1,000 dimensions look like. Because we operate in the 3-dimensional world, right? You can think of a 4-dimensional world to some extent as time, but again, time isn't, you can't move time back and forth, it just flows in one direction. So, what is a 10,000 dimensional space look like? This graph is trying to represent 10 dimensions. And the way it does it, it has an X and a Y axis, okay? And at the point right here, I have another graph and a point, and then another graph and a point, and this is 4 times. So each one of these is 2 dimensions. So I have 2 dimensions, 4, 6, 8, 10. Okay? Let's go to 1,000. Let's go to 12,000. That is the dimensionality that generative AI is representing. Now you might think this makes no sense or is unimportant, but once we start talking about training AI, it's going to be much clearer why this is important. Any questions? Yes?
So here on the example, it means that if we zoom into the peak, if I'm not mistaken.
Yeah.
So it's another vector space.
Right. And then that vector space has another vector space, and another vector space. And we're only doing 10. We could go So like right now, I can, like, if this is my x-axis, I'm walking on the x-axis, right? And I'm walking on the y-axis, and then my height is the z-axis, right? But now every point has another 900 dimensions, or 10,000 dimensions, right? Really crazy. And toward the end, I'm gonna explain why this was so groundbreaking. Because it kind of came from nowhere. Like, ChatGPT was like, what? Like, everyone was shocked. And toward the end, I'm gonna explain some of the process of how we got here. But I'm not doing that right now because I wanna just focus on the current technology. Other questions? Yes?
So what represents the other dimensions?
What are the other, okay, that's a great question. What do the other dimensions represent? We don't know. Doesn't matter. I know that sounds crazy. Once we get to training, it'll make sense. Right now, it doesn't matter what the dimensions are. They don't represent physical space at all. This is physical space, but when you get a 1,000-dimensional thing, it isn't like the first 2 dimensions are physical space or 3 dimensions, and then the rest of them represent something else. No, they're all just dimensions, abstract. Okay, good question. So each dimension in AI is typically a 4-byte floating point value. Okay, so 4 bytes for each dimension. So if I have 1,000 dimensions, I'm looking at 4,000 bytes for a vector. Okay, and those vectors can have the range of those vectors can go from 10 to the 9,000, from 10 to 9,000 to 10 to the 118,000. Now, how many atoms are in the universe? Anybody? 10 to the 80, and on there I got a vector that's 10 to the 9,000 or 10 to the 118,000. Just the space is just unbelievably large, larger than we can fathom. Okay. And again, you gotta, once we get a little farther, it'll start to make sense why this is important. But it wasn't obvious to most people. Okay. All right. Every dimension is typically the same length. Okay. Any questions? We're good. We're going to talk about training now. Okay. So again, the dimensions don't mean anything, as your question was, right? So I was at a conference in Raleigh last year, and somebody gave a semantic search talk. And at that time, this was June of 2024. And at that time, I didn't really understand AI at all. So he gave a talk about semantic search. And I went up to him at the end of the talk, and I said, you talked about this thing called text embeddings. I said, where do they come from? I said, well, how do you train them? And he said, nobody knows. I'm thinking, no, somebody knows. Somebody knows. You may not know, somebody knows. And I went to my boss and I said, I need to understand this. This is important. Because I can't figure out where a database is useful if I don't understand the technology. So I'm the kind of person who basically, I have to go down to the bottom to understand what I'm doing, and then I can go up. But I'm not good at the surface level. I don't like dealing just on the surface level. That guy was just on the surface level. He's like, I don't know where they come from. I'm just going to download them. I'm going to use them. I'm done. No, that's not good enough for me. So fortunately, I have a company, EDB, who's like, yeah, go, take 6 weeks, take 2 months, and just research AI. And I came out with this talk, and I delivered it all year. Okay. So I wasn't happy when the person said we don't know. And I'll tell you, it took a lot of work to figure out this piece of the talk. All right. And in fact, it took so much work. I have 4 URLs here at the bottom, just on my first screen, to explain how I got to this information. Because I just can't find it in one place. It's all spread around all over the place. Sometimes it's on Stack Overflow, somebody's asking a question, somebody's answering. Sometimes it's in a blog, at the bottom, somebody says, oh, by the way, And I'm like, what? Like, come on. So, here's how you do generative AI. Here's how you train it, okay? Because this is fundamental. What they do is they take every word in the English language. Now, we can do other languages. We're just going to do English. There's about 30 to 50,000 words in the English language, okay? So we're just going to take these, we're going to create a vector for every word. And we're just going to randomly put it in this 1,000 or 12,000 dimensional space. Just randomly point them anywhere. It sounds crazy, but that's exactly how I'm told it's done. And the reason it doesn't matter is this space is so big that you would never collide. Like, just, again, it's just huge. Number of atoms in the universe is like tiny compared to this number. Okay? So now, and what they do is they basically tokenize. The other way you can do it, and this is actually more logical, is instead of taking every word, you take 2-byte combinations. And this way we can use UTF-8, Armenian, whatever. So they actually can do, instead of doing words, you can take every 2-byte combination that's possible. And every 2-byte combination gets a vector. And you just point them randomly. So whether you do it by word, or whether you do it by 2-byte vector, 2-byte pair, doesn't matter. You're just randomly pointing these things all over the place. And then you adjust the direction of the vectors using a massive number of training documents. And the technology specifically is something called Word2Vec. And Word2Vec originally was developed by Google. And what it does is it says for each word, adjust its vector to be closer to the vectors in the surrounding words. Sounds completely ridiculous, like it would never work. But believe it or not, it actually does. And I'm going to show you examples of that. Okay? So, let's take a look. This is the classic example for AI. King, queen, man, woman. Okay? King, queen, man, woman. Randomly put them on the screen. Now this is a 2-dimensional, right? Pretend it's 1,000, right? 2-dimensional, I'm just gonna do it in 2 dimensions. So, king, queen, man, woman. And we take a sentence, the king is a tall man, all right? And what we do is we take the vector for the, and we point it toward king. And toward tall and man. And then we take king and we point it toward the and is and tall man, and is moves and moves and tall and man moves. Okay? Now, again, this is just one sentence. Imagine we're going through exabytes of data. The entire internet, every book that's ever published, just massive amounts. Okay? So basically the king is closer, the effect of this is the king is closer to man, tall is closer to man and king. Here's a big sentence here, king is tall man, that's our first sentence. Queen is a beautiful woman, they sit together in the throne room of the castle. So queen and woman are close, beautiful is close to woman and queen, throne is close to castle. Again, because these words are together, they kind of get, the vectors get moved around. Now you might think, oh, this sounds really weird. If tall gets closer to man, then what about like what would be a synonym for tall? Like large, right? So wouldn't moving tall closer to man make it farther away from another word? Not really, because remember, we have 1,000 dimensions. So we can move king, tall closer to man in one of those dimensions, and maybe another dimension we don't move it. All right? There's some mathematics behind it. I'll explain it as I get a little farther.
What exactly means closer here?
Closer in one of the dimensions, basically. So the way, there's something called, anybody know what gradient descent is? Oh, okay. So effectively and that's, remember I showed you the videos in the beginning? Those videos are very math heavy. And they talk about what happens is that you have the vectors all randomly all over the place. And because they're all random, when you have king and tall, there's probably one of the dimensions that they're kind of somewhat close in, and gradient descent kind of looks and says, oh, these are trending to get closer, so therefore those dimensions are going to get close, but the other dimensions, the other 1,000 dimensions, are not going to move at the same time. Okay, so again, you're moving dimensions, you're moving vectors in some dimensions that tend to be grouped together, but then other dimensions you may not be moving at all, but other sentences may move other parts of other dimensions of the vector. All right, and gradient descent actually allows you to accelerate that because you start to get a trajectory of how that's moving, and it kind of moves it multiply. Okay, so again, this is how they all kind of move together. Okay, so when you're done all this training of exabytes of data, what you get is man and woman that are close together, and you get king and queen that are close together. But what's really interesting is if you take king and you subtract man and you add woman, you get queen. Or the other way, if you take woman minus man and you add king, you get queen. So what happens is that the relationships between the words, between the vectors actually has meaning and can be applied in other circumstances. So again, this is a much better description than I'm giving you is here. But just think of these vectors being moved slightly in certain dimensions based on word similarity as they appear near other words in a text. Okay. This is kind of just a visual of what text embeddings look like. Okay. What happened? What happened there? What happened? I don't know what happened there. Go back. I think these are new batteries. Hold on. Maybe I'm losing my batteries. Okay, all right. Is it possible we got some AA somewhere? I don't think I have any extras. Let me try this again. All right, let's try that again. Yeah, it just went, I've just never seen it go like crazy like that. Okay, let's take it back this way. Here we go. Oh, we saw that, okay. Any questions? Yes, sir.
On the previous slide about the vectors, before this one.
Yeah.
Are those exactly the vector addition and subtraction operations?
So the question is, if we're doing, are these really vector subtraction addition operations? So yes, they are, but we don't usually do vector addition subtraction in generative AI. All it's trying to show you is the concept that the king has an aspect of man in it, and it has the same the king has the same aspect of man in it. The queen has the same aspect of woman in it, right? So there's this, somehow in these thousands of vectors, one of the dimensions kind of represents that aspect of the king, and probably another dimension represents the king part. One of them is the man part, and the woman, the king aspect of the king vector is really almost the same as the queen aspect of the queen vector, but the man part is different for the woman. I know that's kind of out there, but again, the mathematics basically cause that to happen. Okay. Okay, no other questions? Okay, so let's talk about semantic and vector search. Okay, now Postgres has had full text search for a long time, since like 2003. There you go. Okay, so but when you do a text search in a database, what are you really doing? You're looking at letters. All right, king, K-I-N-G, okay, man, M-A-N, and you're trying to find other words that have similar letters. When you're doing a semantic search, you actually are using the vector for king and the vector for man, for example, to find similar vectors that will, so you can now understand, we did all that training, you can kind of understand how we're using it because in semantic search, it has a meaning. It's using meanings for these words, and it's using that to do a search, and I'm going to show exactly how we do that here. Okay. So here's the steps we need to do. First, we download a pre-trained embedding, or we create our own. In this case, we're going to use OpenAI embedding because it's been trained. Okay. But if we could train our own, but we're not going to do that. Okay. Then we decide if we're going to do a search. What are we going to search? We're going to search documents, sentences, paragraphs. We have to figure a chunk size. Okay. So we pick our chunk size, and then we get all of the words in that chunk, and we find all the vectors for the words, and we average those vectors. All right, so we take all the words in the chunk, and we find the average of those vectors, and we store that average vector in a database. All right? And then to do a query, we take the query, we find all of the vectors for all the words in the query, we average those words, or average those vectors, and then when we do a search, we find the closest vector to our query vector. The closest chunk vector, okay, to our query vector. All right? All right. So, here's a setup. We're going to have the king is a tall man, the queen is a beautiful woman. They sit together in the castle. Here's our first chunk, king is a tall man. Second chunk, queen. Third chunk, castle. Okay, 3 sentences. So our chunks here are sentences. So here's an example. Who's the king? And we want to find. We would assume we get something like the king's a tall man. Okay. So let's walk through how we do this. How many people have heard of PG Vector? Okay, great. PG Vector existed long before generative AI. For someone just decided to write a vector, and when AI became popular, everyone's like, well, can Postgres do AI? And we're like, well, yeah, I guess you could just download this PG Vector thing and give it a try. And everyone's like, great, and they love it, and it's the weirdest thing. Okay, I mean, we look like we knew what we were doing. So we install PG Vector. By the way, if you want the SQL that I'm doing here, you can download it right here. Okay, so if you want to run this example. So what I do is I create a table called document, where I put my chunks, and I have a second table called document embedding, and that's where I put my vectors. Okay? So I insert into my table the king's tall man, queen's a beautiful woman, sit together in the throne room, and I create an index. Okay? So I create a Python program where I effectively create here's where I take my chunk, I take all the words in the chunk, I average the vectors, and I get an embedding out of it, a vector, and I store the average of the chunk in that SQL table. Okay? And this is what it looks like. Here's the 3 chunks, and here are the vectors. Now I've kind of truncated, it's 1,000, but you get it. They're all 4 bytes for everybody. Okay. So how do I do the query? I effectively, here's where I average my query. I find the average vector for my query. And then I use what we call the spaceship operator, or the nearest neighbor operator, where we basically say, give me the closest vector, chunk vector, to my search vector. Okay? And I order it, and here's an example. Now, who is the king? King's a tall man. That was easy. We could do that with full text search, right? Who is tall? King's a tall man. Again, full text search, no problem. Would have been easy. Who's short? King's a tall man. It knows short and tall are related. That's all. Okay? Who is pretty? Queen's a beautiful woman, it knows pretty and beautiful are related. Because of all that training we did in all the documents and all the adjustment of all the vectors. Okay? Who is in the palace? They sit together in the throne room of the castle. It knows palace, castle are related. Where is the chair? This one's a double use. It knows that sit is related to chair and probably throne is related to chair. Yes, sir.
Is there a way in Postgres to like vectorize the words inside the Postgres and not use Python?
So the question is there ability to vectorize the words in Postgres and not just in Python? Yes, there is. You could do it in Postgres. I just did it at the client because I needed access to the OpenAI embeddings. And if I wanted to do it in Postgres, I could write maybe a PL Python program or a PL Perl program where I actually could access the embeddings. Because the embeddings is like kind of a big file and you've got to like, but I could easily do the computation absolutely in the database, no problem. I would honestly probably do it in Python, but I could, from my PL Python, I could reach into the file system and look up the embeddings and pull them out that way. Interesting question, yeah. So that would allow me to just insert and automatically get the vectors without me having to run a client. Great question. Other questions? Nobody's asked me that yet. That's a good question. Yeah.
What about something store not the raw evidence, but actually quantized evidence? Look like each embedding vector could store as 4 bytes float, but actually it could be 4 bits float.
Right.
And
So the gentleman's pointing out that effectively we could reduce the dimensionality and reduce the scale of each dimension without losing a lot of information. And in fact, when I get to generative AI, I'm going to show that we do not operate in 1,000 dimensions in when doing generative AI. So I think there's still a lot of research that needs to be done to determine, do we really need 1,000 dimensions? Does it have to be 4 bytes? Okay, can we shrink this down? To be specific, DeepSeek, which is out of China, I was actually in Hangzhou, it came out of Hangzhou. One of the, and it came out, I guess, maybe 6 months ago, 5 months ago. One of their big innovations was DeepSeek is able to do generative AI with much smaller vectors and much smaller vector space. And we're now wondering if we've overdone the vectors here. And I think that was your question, that we may not need to go this big that we're
My
doing.
question was about PG vector. Is PG vector linked to just FP4, or maybe there are other?
Right, so the question is, can PG vector do like 2 byte? I think PG vector, I think it can do 2 byte integers, I'm not positive.
I mean,
I'd have to look
I
at
actually
it.
had this situation when we stored vectors in Elasticsearch.
Right.
And we researched if we can move it to Postgres,
Yeah.
which we used as the main database.
Yeah.
But the problem is that in Elasticsearch we had the FP8 pump, I think, and we weren't sure that reducing
Yeah.
scale would be still adequate for our needs. Without research,
Yeah.
we wouldn't just move, right? So, and I think from that time, I think it looked like each vector is hard-coded to.
Hard-coded to 4. I think based on DeepSeek, we're in a process of reevaluating in all the AI technology whether we can do this with a lot fewer storage, a lot smaller
We
vectors.
totally can. Problem, question is about PG vector specifically.
Right. So I know that Google's working on it and they're trying to reduce the amount of storage. So I don't think we've gotten there yet. I think we're only 6 months in and we're moving kind of slow in terms of allowing for these smaller vectors. But I think we need more research, definitely. Okay. Any other questions? Okay. All right. So let's just recap what we did, right? We talked about multidimensional vectors, okay? We talked about text embeddings and how we train them, okay? And then we talked about semantic search, okay? What we're gonna do now is we're gonna take the text embeddings we talked about in section 2 and 3, section 3 particularly, okay? And we're going to now use those text embeddings in another way to do generative AI, because I haven't really done generative AI yet. All I've done is I've talked about multidimensional vectors, and I've talked about how we train them, and I've talked about how to do semantic search, okay? Now we're going to use the same vectors we trained earlier, but now to generate information. And I will tell you, it was very hard for me to put all these pieces together, because a lot of times somebody will talk about semantic search, and I was completely lost, like, well, how does that relate to generative AI? No, it really doesn't. It only relates to the embeddings part, right? And then the embeddings is actually the foundation for both generative AI and semantic searching. It's just in my head, when I write this talk and getting it in order, it's the way you have to do it, okay? So just bear with me. So we're going to be talking about something called transformers. And transformers is the foundational way that generative AI works, okay? So the way they do generative AI and transformers is they basically do something called attention blocks. So attention block is basically they take all the vectors for all the words in the question, and they put them in attention block, and then they run the attention block over and over again, moving the vectors closer to other words in the same question. So when you're typing in ChatGPT, you're effectively getting them to move the vector words, all right? And I'll explain how the generative part works at the end. And then just keep doing it over and over, and at the end they get the words, okay? I know it sounds very vague, let's be specific. Okay, so let's talk about attention blocks. Again, as I mentioned before, they're much lower dimension, only 128 dimensions, okay? And the attention block typically runs 96 times. There's also a bunch of stuff I didn't cover, but again, this is just a very basic talk. So this is basically what happens. The question is, the query is, what is the capital of France? Okay, what is the capital of France? And what I do is I go to the text embedding and I find the vectors for each of the words in the question. And I load each of those vectors into this attention block, all right? So what is the capital of France? There's my vectors. Okay. So what I do is again, this seems completely ridiculous. I move I move is closer to what, okay? So now the first vector is what, and the second vector is not what is anymore, it's what is closer together, okay? And then I move the closer to what and is. So now I have what is, and what is the, okay? And then capital gets moved closer to those words. And then of, and then France, and then a question mark. So this is at the end of the first attention block, my vectors are now moved, right? And then I do it again, all right? So I normalize them, I do a bunch of things to kind of, something called back propagation, another mathematical idea here, to allow you to get, to look at trends in the attention blocks. So this is attention block number 2. I'm moving vector 2 closer to vector 1, vector 3 closer to vector 1 and 2, and I do that over and over again, okay? I get this, okay? This is my third attention block, this is my fourth attention block. So all I'm doing is I'm taking the original embeddings for the words of the query and I'm moving them all closer to each other, okay? And after I run this 96 times, at least for ChatGPT 3, what happens is the last vector, I take the last vector, after I've run 96 times, and I go back to my embeddings, and I say, give me the word in the text embeddings, give me the vector that's closest to this vector, the last vector, and then I want to use, that's my first word I'm going to answer to the person. Now, you might think I'm making this up. When you use ChatGPT or any of the AIs, you might notice that the way the words appear, they appear one at a time. they typically don't appear all at once. And the reason they appear one at a time is because it's literally generating the words one at a time. Okay? So that is my first word. And then I run it again, and that's my second word. And I run it as many times as I want. Now, this is very simplistic. It doesn't talk about sentence structure. It doesn't show me when I finish. There's a whole bunch of details I'm not showing you. But effectively, this is the way it works. Okay? And here's word number 2, right? I take vector 8, I go look it up, oh, that's my next word. And I just run it again, and I keep running this attention block. And there are some optimizations that allow me to run the subsequent attention blocks faster. But again, this is just simplistic. Okay? This is what word is I'll generate word 1, word 2, and I just keep going. Yes?
Can you go back 2 slides? No? Yeah, here. As you can see, the word what is the most frequent. So, you're saying that in ChatGPT, when we are asking questions, the first words are the most impactful. They're making most impact on your on generating the answer.
Okay, so the question was, it looks like the first word has the biggest impact on and it's kind of true in this example. Now, I'm not sure what or the actually are processed. I think they get thrown away. Frankly, I think they're throwaway words, but I think what probably does stay. I understand what you're saying. It looks like the early stuff has more impact. I don't know once you go through 96 cycles if that's still true, but I don't know the answer actually. Yeah, I see what you're saying though. Yeah, that's a good point.
So,
Yeah.
do we have any dependency between answer words, word 1 or 2, or they are completely independent?
So the way it starts out, this is the first word of the query, this is the second word of the query, this is the third word.
No, I'm asking about answer words. Because algorithm you describe it, that word 1 you found is independent from word 2, or vice versa.
Okay, so the question is if you get, so basically this second word is kind of dependent on the first word because you basically just take this word and just run it over again, and then vector 8 kind of leads you to vector 9 basically. I don't really understand the mathematics of how they, because there's a whole sentence structure that I'm not even showing here. So I'm not, it's possible I'm just kind of, I've shown this to enough people that this is accurate. Nobody said it's wrong. But again, it's much generalized to what it would normally be. You can't drill down too much.
They actually dependent on each other because algorithm is basically recursive. When you, your first word of the answer is actually added to your question. There is no distinction between answer questions.
That's true, yeah.
So
The next word is part of the question, yeah.
Okay.
That's a great point. I like that point, yeah. You answered it for me, good. Other questions? Okay, so let's look at this in action now that we've kind of understood it. So I'm going to use ChatGPT 4, okay, and I'm going to ask it, what is the capital of France? And the answer is the capital of France is Paris. Now, how did it do that? Well, probably what and the and of are probably not that important, but what basically happened is France and capital. Now remember I did king and queen, and I talked about that? I believe what happens is when you take France and you start to combine the vector for capital with it, it ends up pointing at Paris. This is getting back to the king-queen example. What happens is that effectively there's an attribute of France which has a capital, there's an attribute of Paris which points to capital and points to France. And somehow when you put the France and capital together, it ends up pointing it at Paris, and that's how the answer comes out. I can also ask it in a different way, I get the same answer. Kind of expected, right? It doesn't matter really whether, this is interesting, where is Paris? And it comes out with a huge description of Paris, which is kind of cool, right? Now, if I say Columbus is in Ohio, where is Paris? it gets confused. Because, again, it's not a straight point at Paris anymore, right? Or it's not a straight point at France's Paris, because it says Paris is in France. There's also a city in Paris in the United States, in Texas. So it kind of hedges its bets. It's like, well, my vector kind of points at the France Paris, but there's also a Texas point, right? If I say I live in Texas, where's Paris? Now I'm pushing Paris very close to Texas, and now I get a description of Paris, Texas. And then a description out here about the France Paris. Right. Well, actually, this is Eiffel Tower replica. That's this is the only part right here. This is where I got the France part. Okay. You can kind of see a little bit of how that adjustment is happening. Right. Any questions? Okay. So let's talk about retrieval augmented generation. We're now going to get back into the database piece about where databases make sense. Okay, retrieval augmented generation is a big part of database use for generative AI. And what you basically can do is have the database prefix some information that gets sent to the generative AI. All right. So you're not doing the generative AI in the database, you're still doing the generative AI externally, but the database is supplying prefix information, which will affect, remember how I said, I live in Texas, where is Paris? That I live in Texas could be a prefix, okay? So I can say, where is Paris? Now here I say, if I prefix it with reply briefly, I get a much shorter answer than if I do it without it, okay? So here's what it would look like. I can actually look internally. What happens is we have a special way of passing sort of context information to the generative AI, and you can use databases for this. So here, Columbus is in Ohio, where's Paris? Again, we get a better description. I live in Texas. Again, I get more of a Texas description, okay? I think this is a great use case. What I did was I generated some JSON of some invoices. And I prefixed every query with this JSON. And let's see what generative AI can do with some JSON, okay? So, if I say, when were the orders made, ChatGPT absolutely understands the dates of the orders, just from the JSON, okay? What is the earliest invoice? It understands the dates. Look, it says February 4th, 5th was the first invoice. What is the total of all invoices? It actually can total them up for me. What is the average invoice amount? It computes an average. Right? Today's April 15th. What is a 30-day payment? Which invoices are overdue? It understands overdue invoices. You can start to see how taking some data from a database and passing it to generative AI allows for natural language queries of that data. This is revolutionary. Yes?
Is it going to be persisted in the model, or is it kind of
So the example question is that persistent in the model? The answer is no. The embeddings are not changing at all because of the queries. That's both good and bad. It's good because your data doesn't get mixed in with other people's data. It's bad that you don't have persistence. If you need persistence, then you probably either need to do your own text embeddings, train your own, or you can download a text embedding and then you can supplement it with your own training data and slightly modify it and use that embedding, which has the standard embeddings from the whole internet, plus some information specific to your company, which would be persistent.
Is this kind of practical? I mean, is this used in the production?
Yeah, is it practical? Absolutely, yeah. Training, for example, if you take a text embedding and then you get all of your product information and you train an existing embedding, add in your own product information, now the embedding can answer in natural language in questions about your product. Yeah.
So what about the hallucinations that it makes or don't predict? the AI? In this case, like if you're using the production for a product.
Yeah,
just-
so and the question about
It's a good idea.
hallucinations, okay, so I was in Riga in October, and somebody asked about hallucinations, and we had an AI session as part of the conference, and I said, everyone looks at hallucinations and they think, oh geez, why did the AI not work? Why did it do something different, right? And the answer is, AI is always hallucinating. The concept of hallucination is something that we place upon the AI when we say deliver the wrong answer. But effectively, when an AI is giving a good answer and it's giving a hallucinating answer, the AI is doing the exact same thing. So there is no fix for hallucinations. It basically means that the statistical prediction of words just didn't work in that particular case. But if there's nothing inherently broken about hallucinations, it's fake. We decide what's hallucinations and what isn't. It's not really the AI doing something wrong in certain cases and not. So what happens in hallucinations typically is that the vectors, because of the training data, are getting confused. They're pointing at the wrong direction. They're pointing at the wrong words, and you start to get answers that don't make any sense.
Yeah, but in that case, is it a good idea to use AI? If it's
Well,
like
maybe-
everything for your product.
Yeah, then you absolutely open yourself to problems because AI is unpredictable. Yeah, you're absolutely right. Yeah. I think it makes a little more sense maybe for internal use, maybe not external right away. Make sure, and there are a whole bunch of cases where people review the answers to find mistakes, and there's a whole bunch of checks that you can add to it. There's a question.
As you mentioned, there is a code base and there is a memory in cloud AIs. Are they the same or really different? As you mentioned, on every request we have a context, but for example, in ChatGPT there is a memory. And remember your first questions and answer them. Does it say it in their memory or it's a different one?
Okay, so the question's about context. Effectively, the way, when you run ChatGPT now, from a web browser or an app, I'm just giving you an example. Typically, you will start a question, and then every subsequent question will use the context of the previous questions to continue to refine the answer, okay? If you then go to the top left and you say new question, then it forgets everything and now you're answering with no context at all again. So again, usually early versions of ChatGPT had a context of maybe 1,000 words. Now some of the newer models have 1,000,000 word context. And all of a sudden you can send whole documents as context to a question, right? And that's super powerful. So you're absolutely right. The context issue is very important. It has to do with how wide the attention block is, because the attention block sometimes can't hold a big number of words. But you're absolutely right. That's a great example of this because it's that context that kind of drives how the words come out. Yeah, and you can either do it remembering the context, or you can ask, I'm going to ask a new question, and then it forgets all the context and then starts brand new. But we're not adjusting the embeddings at all during this. It's just the way, it's how the attention block's loaded. How do we load the attention block? What goes into the attention block? That's what that memory part is, that context. It goes before the actual question. Good point. Okay. What's the total invoices that are not pencils? It knows that. Okay. What is the next expected order date? It can figure that out. It can generate SQL, which is kind of cool. Here's a cool example. I basically used Postgres to generate JSON, and I use that as my context to the question. All right, just a little more, this is a more realistic. I'm basically generating all the invoices for a specific customer, and I'm prefixing that with whatever question they ask. And there might, to the question there, I might give a whole bunch of context to every customer. Where are they located? What's their industry? Like a whole bunch of stuff I can prefix to a question that may give them more accurate answers. Okay. Yeah.
So which model is
This is ChatGPT.
this?
4.
4?
4.0 mini. 4.0 mini. It says right back, way back here, it said. Right here. No. Right back, anyway.
It's go forward.
No, I thought I did it here. No?
No, it was.
Oh, it was on 6? Okay. Yeah, I know I said it somewhere. Anyway, it is
There was a
ChatGPT.
Python code.
The Python, yeah, well, okay. So it's in the Python code. Okay, yeah, here it is. ChatGPT 4.01 mini. That's what it is.
Have you tried with the latest ones like 5?
No, I haven't tried it yet, no. Okay. So anyway, this is an example of a loading. Okay. Last section. We're 2 minutes over. Okay, so this is a summary of what I've talked about. Here's my embeddings that I've trained. Here's my random embeddings. Here's the training data. Here's the trained embeddings. Okay. Here's my semantic search where I put chunks in. I store my chunks and I look up semantic queries. And at the bottom, here's my generative use of the vectors. Okay? That's just a summary slide of what we're doing. This is the key slide, I think, for the presentation. Okay? What it does is it talks about all the aspects of generative AI and it determines which are good to do in the database and which are not. So, semantic vector search is good, RAG is good, language queries good, data analysis good. Something I didn't even talk about is model context protocol, MCP. That is absolutely good with the database. I didn't even cover it. It didn't exist when I wrote this talk a year ago. That's how fast the industry's moving. Okay. Somebody asked about training vectors. This is talking about different ways you can either download pre-trained vectors and add to them, or train your own vectors. A whole bunch of stuff you can do. I've given you very basic stuff here. Okay, but again, if you dig into this, you almost have to download the slides to kind of walk through them and then start to look at some of these these links here. Postgres solutions, we've already talked about PG Vector. We have PG Vectorize. My company has one. Timescale has one. We've got a whole bunch of AI chatbots. DB2 does AI server programming, generative AI. This isn't really generative. This is more discriminative, but that's okay. Okay, so how did we get here? Google invented most of this technology. All right? They invented word2vec, they invented attention blocks, but because they basically were so worried about their search, they didn't implement generative AI. They didn't see the value in it. And that's why ChatGPT made a big jump over them, probably because they just weren't focused. They didn't want to cannibalize their business, their advertising business, and ChatGPT basically. Now I have heard that, actually you told me, Emma, Gemini is very good. So Gemini's trying to catch up now.
But that's DeepMind. This doesn't do.
What's this?
That's DeepMind.
Oh, DeepMind is the one you like.
It's Gemini is more Google DeepMind, not Google.
But Google
Why?
acquired
Google
and now invest.
Oh,
much
Gemini,
in Gemini 3.
underneath Gemini is DeepMind. Is that what you're saying?
Yeah.
Oh, okay, I didn't know that. Okay. So anyway, they're trying. Last 2 sentences and we'll finish. Both of these statements are true. And it's just confusing, but they're both true. This is done in 2023, a year ago. If you said to me in our lifetime we'd have the capabilities we have in ChatGPT 4, and if you explain the kind of things it can do, I probably would have said to you a year ago, I don't know if we will have those in our lifetime, and now we have them today. So the speed at which it's moving is staggering. Very, very true. But the second thing is also true. We are used to the idea that people or entities that can express themselves or manipulate language are smart. But that is not true. You can manipulate language and not be smart, and that's basically what LLMs are demonstrating. All they're doing is statistically predicting words from vectors. Okay? That does conclude my talk. I'm sorry I'm 6 minutes over, but we had some really good questions, and I want to thank you. I'm looking forward to coming back this evening.
Sorry, can you make the presentations?
Oh, sorry.